Well, here's my electromagnetic detector with the little LED. I'm just literally on my street at the moment. That's my house up there, end of my driveway, car going up there. And I've got some power lines along the street, not for much longer. They're literally in the process of putting the underground cables in. But as you can see, there's my LED lighting up. I'll just walk along the street. And yeah, so I'm literally, hey, can't exactly run a whole household on this, but it is showing that the detector is quite sensitive, because I can walk along the street here, as you can see, and oops, I turned that around the wrong way, so it's quite directional. And you can see it's lighting up just from the power lines. I'll try to get the power. Yeah, you can probably just see the lines there. So, yep, it's pretty dark still. So, where are we? Here we go. Yep. So, there you go. Now, I'll just turn around and move away from the power lines. It's dimmed a little. There you go. Phantasmalogic. So yeah, so it definitely it works. So it's not super exciting, but that's actually not bad. Now, with this particular system, you could easily, instead of having the LED there, have the exact same setup and have a digital voltmeter, which would then show you, weaker fields, whereas where the LED won't light up. Of course, you could still be reading volts and down into the millivolts and stuff like that. But yeah, so I've sort of lost it here, and this is the end of the line, the power line here. I'm trying to get that to show. Yeah, so this is the very end. But yeah, these won't be here for much longer. Now notice at the end I'm really not getting much. But as I move along, let's see, along the line, oops, I was aiming the wrong way as well, not helpful. Yeah, so I'll run back and try that again. Coming back to the end, because I was probably just holding it the wrong way. But, oh no, it does drop off a bit at the end. There we go, yeah. So, there you go. Very exciting, of course, very dim now. It even lights up when I touch my range hood in the kitchen, just from a bit of earth noise. And I'll show you how it's good for finding other noisy devices. Down here I have a battery charger. It's not connected to the battery, so it's reading as off. And I'll bring in the detector. Oops, I get the angle right so you can see the light, and you can see the lights on. I'll move away. Yeah, I'll get to that point. You notice you can see the pulsing. So it's actually quite good at picking up even weak fields like that. So it's using a 3 or 4 volt LED globe. And the basic configuration is there's 2 elements. I'm using a fiberglass rod with copper tape over it and with a gap in the copper tape so that it's 2 separate conductors. And I've got a toraflux or torus on one side, and my hand holds the other side, so I act as the other side of the system. And so here's my really artistic picture of the LED, and it's the type with the the center pin as the positive, and then that section there, the screw-in bit, as the negative. So how it's configured is each element has a push-pull with the LED. So this element has a diode with the direction going to the positive of the LED, but also this element has a diode going to the positive of the LED as well. And then we have the inverse, where from the negative of the LED, we have a diode going out to this conductor, and also one going out to this conductor. So this conductor has push-pull, and this one has push-pull. I did that the wrong way around, but you get what I mean. And so that is the basic idea. You could, of course, add a digital voltage meter instead of the globe, and then you would get much more detailed readings going down into the lower volts and the millivolts. And it's also good for higher frequencies. So right now I'm doing a transmission on the 40 meter band at 7.191 megahertz, 5 watts on an experimental indoor antenna. And as you can see, even as I move away, that's actually still lighting up quite well. So 7.3, and thanks for watching.